Hi, in this video we are going to solve exercise 3 about exponential function. 3 part A, we have a function g defined on R by gx equals 1 minus into x plus 1 e to the x. Part A, calculate limit as x tends to minus infinity of gx. To calculate the limit as x tends to minus infinity, we replace x by minus infinity. Minus infinity plus 1 is minus infinity, e to the minus infinity 0. So indeterminate, we put ex in the denominator and we apply Hospital's rule. So limit as x tends to minus infinity of gx equal as x tends to minus infinity 1 minus x plus 1 e to the x equals, we can expand 1 minus x e to the x minus e to the x. A property, this one is 0. X e to the x as x tends to minus infinity is 0. Then 1 minus 0 minus 0 equal 1. Then we can say that y equal 1 is a horizontal asymptote. Not necessary to say horizontal asymptote. Limit as x tends to plus infinity. This one becomes plus infinity times e to the infinity is infinity. It becomes infinity. 1 minus infinity is minus infinity. Part B. Show that g prime x equal minus x minus 2 e to the x and set up the table of variations. Now g prime x, derivative del 1, 0, minus u prime, derivative del x plus 1 is 1, u prime is 1 times e to the x, minus v or plus v prime, which is e to the x into x plus 1 times بتصير minus x plus 1 e to the x. We can take e to the x common. It becomes minus 1 minus x minus 1. It becomes minus x minus 2. This is what's required. To set up the table of variations, we take g prime x equal to 0. Then minus x minus 2 equal to 0. So x equal minus 2. Now, table of variations, x, g prime x, gx. Limit domain minus infinity plus infinity. At minus 2 it is 0. Now to know the sign after minus 2, if I take 0 and I replace it in the derivative, g prime of 0 is minus 2, it is negative. So negative here and positive here. Negative, at minus infinity we get 1, it is increasing. The maximum g of minus 2 is 1.14. Decreases at plus infinity, the limit is minus infinity. Calculate g of 0 and study the sign of gx. G of 0 equal 1 minus 0 plus 1 is 1. So 1 minus 1 is 0. G of 0 equal to 0. Then deduce the sign of gx over r. So to deduce the sign, I make sign table x gx minus infinity plus infinity 0. At 0 it is 0. To know the sign, I take a number greater than 0, like 1. If I replace it here in gx, g of 1 will be 1 minus 2e, 1 minus 2e, which is negative. So here negative, here it is positive. Part B. We have the function f defined on R by fx equals 2 plus x over 1 plus ex. and C is its representative curve in an orthonormal system. Part 1, calculate the limit as x tends to minus infinity. Limit as x tends to minus infinity, it will becomes 2 minus infinity e to the minus infinity 0. So minus infinity over 1 is minus infinity. Part 2. Show that fx minus x plus 2 equal minus x minus 2 over 1 plus e to the minus x, and prove that the line D of equation y equal x plus 2 is an asymptote to C at minus infinity. So to verify this, fx minus x plus 2, this is fx minus x plus 2, we take the LCM, 2 plus x minus x plus 2 into 1 plus ex over 1 plus ex. We take 2 plus x common. If we take x plus 2 common, remains 1 minus ex remains minus ex. So it is minus into x plus 2 e to the x over 1 plus ex. As you notice, we needed to verify it. It is minus x plus 2 over e to the minus x. I put this ex in the denominator. It will becomes e to the minus x. This e to the x, I put it down. It becomes e to the minus x. Yeah, not necessary, then it becomes minus x minus 2 over 1. E to the minus x times 1 is e to the minus x. E to the x times e to the minus x, e to the 0, which is 1. Now to prove the line D is an oblique asymptote at minus infinity, we determine the limit, the fx minus y as x tends to minus infinity, equal limit as x tends to minus infinity of minus x minus 2 over 1 plus e to the minus x. We will get plus infinity over plus infinity indeterminate. We'll get infinity over infinity indeterminate. We apply Hopital's rule, equal limit as x tends to minus infinity. Derivative of minus x minus 2 is minus 1 over minus e to the minus x. It becomes minus 1 over minus infinity. It will be 0. Then we say y equal x plus 2 is an oblique asymptote to C at minus infinity. Study part 3. Study the relative position of D and C. Fx minus yd is minus x minus 2. If we solve it equal to 0, it means that minus x minus 2 equal to 0. It means that x equals minus 2. I put x, fx minus y position, minus infinity plus infinity minus 2. If I take a number here like 0, minus 0 minus 2 is negative. So here negative, and here it is positive. Positive, we say C is above D. Negative, C is below D. Is that x minus 2, y equals minus 2 plus 2, which is 0. So minus 2, 0 is the common point between C and D. Prove that the x-axis, prove that part 4. Prove that the x-axis our axis of abscissas is an asymptote to C. The x-axis is an asymptote to C. The x-axis of equation y equal to 0. So limit as x tends to minus infinity, we get limit as x tends to minus infinity, or as x tends to plus infinity. Limit as x tends to plus infinity, we get infinity over infinity. Limit as x tends to infinity over infinity, Hopital's rule equal 1. Limit as x tends to plus infinity, this one, of 1 over e to the x, epsilon over infinity equal to 0, then y equal to 0, or the x-axis is a horizontal asymptote. Part 5, show that f prime x equal gx over 1 plus e to the x squared, and set up the table of variations. So we have fx was fx is 2 plus x, fx equal 2 plus x over 1 plus e to the x. F prime x equal u prime, which is 1 into v, we get 1 plus e to the x, minus v prime is e to the x times 2 plus x, we get minus 2 e to the x, minus x e to the x over 1 plus e to the x squared equals 1 plus e to the x minus 2 e to the x. Gx was minus, I get 1 minus x plus 1 over 1 plus ex squared, which is equal gx over 1 plus ex squared, means f prime x takes the same sign as gx. Since 1 plus ex squared is positive, then f prime takes the same sign as g. The sign of g is determined here. Before 0 it is positive, and after 0 it is negative. So f prime x has the same sign as gx. Before 0 it is positive, and after 0 it is negative. Increasing, decreasing. F of 0 equals 1. The maximum is 0, 1. Al minus infinity, we get minus infinity. Al plus infinity, the limit is 0. Show that our plot DC in the same orthonormal system. The line D of equation y equals x plus 2 is x equal to 0, y equal to 2. With an x equal minus 2, y equal to 0. This is the oblique asymptote. The maximum is 0, 1. This is the maximum. The intersection between the curve and the oblique asymptote is minus 2, 0. So the curve here is above the oblique asymptote. Here it intersects the oblique asymptote at 0, 2, goes to the maximum, then it goes near the horizontal asymptote y equal to 0. Y equals 0. Part 7. Let h be the function defined by hx equals len 1 minus fx. Determine the domain of definition of h. To determine the domain of definition of ln function, the function inside ln should be positive. It means that 1 minus fx positive, it means that fx less than 1. Fx less than 1. We notice here all the curve is below the line y equal 1 except at 0. At 0 we get 1, so domain of definition is minus infinity, 0 union 0 plus infinity. Part B. The graph of h has a vertical asymptote and a horizontal asymptote. Find the equation of these asymptotes. So, to determine the asymptotes, limit as x tends to 0, limit as x tends to 0 plus equals len 1 minus f of 0. Limit as 0, we get limit as 0, or f of 0 is 1 equal 1 minus 1, which is 0. Len 0 is minus infinity. So limit as x tends to 0 equal minus infinity. Then we say x equals 0 is a vertical asymptote. Now limit as x tends to plus infinity also equals 1 minus len 1 minus f of x as x tends to plus infinity. As x tends to plus infinity, fx tends to 0. It will become len 1, which is 0. So also we get here y equal to 0 is a horizontal asymptote at x equal plus infinity. Y equals 0 is a horizontal asymptote at plus infinity. To set up the table of variations, we have h prime x. Derivative of len u is u prime over u in equals minus f prime x over 1 minus fx. 1 minus fx is positive. Minus f prime in h prime x has the opposite sign of minus f prime. Has the opposite sign as minus f prime. F prime before 0 it is positive. After 0 it is negative. H prime has the opposite sign. So here it is negative. Domain is minus infinity 0, plus infinity, negative, positive, decreasing, increasing. It is not required to draw the curve. Or if you like to draw the curve, this is the curve. Now exercise 4. We have the function f defined over 0 plus infinity by fx equals x minus e to the ln x over e to the x. And c is its representative curve in an orthonormal system. Domain is 0 plus infinity because we have ln x. X should be positive. Determine the limits at the boundaries of the domain of definition. Limit as x tends to plus infinity, we get x minus e to the ln x over e to the x. We get plus infinity. This one is plus infinity over plus infinity. We apply Hospital's rule. We apply Hospital's rule here. It will become limit as x tends to plus infinity, e to the ln x over x. If we use Hospital's rule, it will become derivative of ln x is 1 over x. well, e to the x is e to the x. It becomes e to the x, e to the x. As x tends to infinity is 0, so plus infinity minus 0 is plus infinity. I repeat, e to the ln x over e to the x is infinity على infinity. Apply Hospital's rule. Derivative ln x 1 over x over e to the x بصير e to over 1 over x e to the x, which is 0. Now limit as x tends to 0 plus, هيدي 0. Ln 0 is minus infinity, so we get plus infinity. Now, part 2. Let g and h be two functions defined over 0 plus infinity. Gx equal x e to the x and hx equal e to the 1 e into 1 minus x ln x. In the following figure, the curves g and h are represented by represented here in an orthonormal system, the two functions of g and h. So this is h, the curve of h, and this is g. Write f prime x in terms of g and h. F prime x, derivative of x is 1. U over v, derivative of ln u prime is e over x times v e to the x minus derivative of e to the x is e to the x times e to the ln x over e power 2x over v squared. We take the LCM, it will becomes this is not x e to the 2x, it is 1 e to the 2x, this one. Or we take the common denominator first here. بننزل الx لتحت. First step. It is equal 1. This is e to the x. It will becomes e times e to the x minus e times x times e to the ln x over x e to the 2x. I take the common denominator x e to the 2x, بصير x e to the 2x minus e times e to the x plus ex times e to the x ln x over x e to the power 2x. I can take e to the x common. It will become x e to the x minus e plus e to the ex times ln x, e to the x times ln x. We simplify if we want this one and that one. X e to the x is gx minus hx, gx minus hx. E to the x e to the x is gx, and this one is minus hx. Construct the table of variations. F prime x equal to 0 means gx minus hx equal to 0 means gx equal hx. gx equal hx. يعني x graphically x equal 1. before 1 g is below h. So gx minus hx will be negative. So here we put negative, here we put positive. Or if you like, you can take a value which is greater than 1 and you replace it in fx. You know it is positive, and if we take, for example, x equal to 2 minus e ln 2 over e squared, it will be positive. So here positive, here negative, or graphically. Decreasing, increasing. At 0, the limit, we get the limit plus infinity. على plus infinity, the minimum f of 1 is 1, len 1 is 0, so 1. The minimum is 1, 1. E. Prove that the equation fx equal 2 has two solutions, alpha and beta. Alpha between 0.45, between 0.4 and 0.5. So I can say the following. Over 0.4, 0.5, the function is continuous and strictly decreasing. F is continuous and strictly decreasing. I calculate f of 0.4 and f of 0.5. One of them is less than 2 and the other is greater than 2. One of them is less than 2 and the other greater than 2. By the same way, over 2.2, 2.3, the function is continuous and strictly increasing. F of 2.2 will be less than 2 and f of 2.3 will be greater than 2. Then the equation fx equal 2 has one solution beta, and beta is between 2.2 and 2.3. Part 3. Draw C. This is the orthonormal system. The minimum is 1, 1. At 0, limit at 0 is plus infinity. We have a vertical asymptote. And we take some particular points. So here the curve is decreasing from near the vertical, which is the y-axis, to the minimum. Then it increases to plus infinity. It is better to take some particular points using your calculator. Or we can draw the line y equal 2. The line y equal 2 cuts the curve at 2 points. The first one is between 0.4 and 0.5. And the second one is between 2.2 and 2.3. This is 2.2 and 2.3. And we can take particular points. Three. Let u be the function defined by ux equal len fx. Determine the domain of definition. To determine the domain of definition, fx is positive. Here fx is positive for every x belongs to 0 plus infinity, so the domain is x greater than 0. Now study the variations of u. U prime x equal f prime x over fx means u prime has the same sign as f prime, F prime, before 1 it is negative, after 1 it is positive, decreasing, increasing. To find the minimum, u of 1 equal len f of 1. F of 1 is 1 equal len 1, which is 0. Limit على plus limit على 0 تعطينا u equal limit len 0. len 0 معنى إياها plus infinity. len plus infinity is plus infinity. على plus infinity we have len plus infinity. The limit of fx على plus infinity is plus infinity. Len plus infinity is plus infinity. Exercise 5. We have this table below. Is the table of variations of the function h over r. hx equal ax plus b e to the minus x plus c. قلنا show that a equal b equal minus 1 and c equal 1. First value f of 0 equal 0. أو h of 0 equal to 0. h of 0 بتصير b e to the 0 which is 1 يعني b plus c equal to 0. Now, second one. We can also h prime of 0 equal to 0. So h prime x is a u prime v, a times e to the minus x, minus e to the minus x into ax plus b. We take e to the minus x common, it becomes minus ax plus a minus b. H prime of 0 equal to 0, a minus b equal to 0. Now, limit as x tends to plus infinity is 1. The limit as plus infinity of this one is 0. So we get c is equal to 1. C equal to 1, b plus c equal to 0, يعني b equal minus c equal minus 1, a equal b, so we get this one. Prove that hx is greater than or equal to 0. Since the minimum of hx is 0, means hx greater than or equal to 0 for every x belongs to minus infinity plus infinity. Part B. Consider the function f defined over R by fx equals x plus 2 e to the minus x. Part 1. Determine limit at plus infinity and at minus infinity. Limit at plus infinity, we get infinity plus infinity times 0 indeterminate. We can put e to the x in the denominator and we use Hospitals, or we can expand. If we expand, it becomes x e to the minus x plus 2 e to the minus x. This one is a rule, the limit is 0. We get infinity plus 0, we get plus infinity. This is plus infinity. This will be plus infinity. Limit as x tends to minus infinity, بتصير minus infinity times plus infinity, بتصير minus infinity, which is minus infinity. Prove that the line D of equation y equal x is an asymptote to c at plus infinity. So limit as x tends to plus infinity fx minus yd, fx minus y at d, x minus x 0. We will get infinity times 0. نزل ex لتحت, or we can expand. Hospital's rule بتصير limit derivative للx plus 2 1 over ex equals 0. So y equal x is an oblique asymptote. Study the relative positions of C and D. Fx minus y equal x plus 2 e to the minus x. We solve it equal to 0 in x equal minus 2. Negative, positive. Negative C is below D, positive C is above D. Point of intersection is minus 2. Is that x equal minus 2? Y should be 0, not minus 2. This one. It will be minus 2, not okay. It will be minus 2. Correct this one. Show that f prime x equal hx and set up the table of variations. So fx, we have it equals x plus x plus 2 e to the minus x. F prime x equals 1 plus u prime v e to the minus x minus e to the minus x into x plus 2 equals 1 plus e to the minus x minus x minus 1 equals hx, which is hx, and we know that hx is greater than or equal to 0. F prime x has the same sign as hx. It is positive, so it is increasing from minus infinity to plus infinity, not necessary to put 0. Prove that the equation fx equal to 0 has a unique root alpha, and alpha is between minus 1.69 minus 1.68. F is continuous and strictly increasing over minus 1.69 minus 1.68. Then f of minus 1.69 is negative, f of minus 1.68 is positive, so the equation fx equal to 0 has 1 root alpha. Part 4, draw D and C. Line dy equal x. The point of intersection between the curve and the oblique asymptote is minus 2, minus 2. F of 0 is equal to 2. By using the particular points, the curve is increasing. It passes by the point 0, 2, and it goes near the oblique asymptote. Okay, this is all for this exercise. Remains exercise 6 and 7. You can solve them alone. Prepare well for the mid-year exam. If you have any questions, you can ask me. See you.